Hey guys, how are you? This is the first lecture of thermodynamics, and I'll be teaching you from the basics. Okay? Hi, very good evening. Very good evening. सर बिगनिंग से पढ़ाएंगे या फिर बेसिक स्किप करके? बिगनिंग से बिल्कुल बेसिक से पढ़ाऊंगा, बिल्कुल बेसिक से पढ़ाऊंगा. And the medium of instruction will be in English for these YouTube lectures. Okay? So let others join, and then we'll be starting with the first lecture of thermodynamics. Okay, and I'll be teaching you from the basics. Don't worry, I'll be covering everything. I'll be teaching you system, surroundings, that from that basics. Okay, so don't worry about that. Hello, good evening. I'll be reading your comments on my phone here, and yeah, because I'm not able to see your comments on the screen now. So I'll be reading your comments in the phone. Okay, good evening. Okay, so it's 6:01, and let us start with the lecture. Okay, so first of all, my introduction. You know me as Viresh Kumar. Okay, Viresh Kumar. You can find me on Unacademy by the same name, Viresh Kumar. Okay, many of you know me by Viresh Manocha, but do not search me by the name Viresh Manocha. Okay, on Unacademy my name is Viresh Kumar. Okay, I've done my MTech from IIT Bombay. IIT Bombay, heaven for you guys. Okay, so this place is heaven. I had my most memorable days at IIT Bombay. Most memorable days. Okay, along with teaching thermodynamics, I'll be telling you the stories of IIT Bombay, and also I'll be posting one picture daily to motivate you, and that picture will be from any of the IITs. Okay, and you have to guess the picture, and that picture will be included in the lecture only. Okay, in the middle of the lecture you will be having that picture, and you'll have to guess that place, and I'll be motivating you to prepare for GATE, to get a good rank, to go to this place, this IIT. It's literally heaven. I had the most fun-filled time of my life at IIT. Okay, so I have 4 years of teaching experience, and I'll be taking subjects heat transfer, basic thermodynamics, which I'm starting here on YouTube, and fluid mechanics and engineering mechanics. Okay, engineering mechanics I'll be taking in RIB batch, rank improvement batch, that we are going to start from 15th June on plus. Okay, so in that batch I will be taking the engineering mechanics. Okay, let me read the comments. Yeah, sir will provide notes. Yes, you'll get the notes. The link will be there in the description after this class. Okay, will you take this class daily, sir? No, I will be taking this class on alternate days. Okay, like Tuesday, Thursday and Saturday. Okay, साउंड थोड़ा एको हो रहा है. Okay, I think I'll put some curtains in this room from the next lecture, but इस lecture में तो ऐसा ही करना पड़ेगा. तो in the next lecture I'll put some curtains so that this echo thing gets away. Okay, yeah. Sir, will you provide PDF? Yes, I'll provide the PDFs. Okay, next slide. So this is the YouTube schedule for Unacademy GATE and ESE. Okay, do follow this channel. Ask your friends to follow this channel for this schedule. Okay, so for Hindi medium guys, the classes will be conducted from 7 AM to 10 AM. Okay, Amit Dixit sir is taking vibrations from 7 AM to 8:15 AM. Okay, and he will be teaching you from Monday to Saturday. And then from 8:45 AM to 10 AM, Alok Jha sir is taking Theory of Machines Part 1. Okay, and he'll be taking this subject on Tuesday, Thursday and Saturday. Okay, and Monday, Wednesday, Friday, Apurup sir, MTech from IIT KGP, he'll be taking strength of materials, and he'll be teaching you strength of materials by this question series. Okay, and he'll be taking class on Monday, Wednesday, Friday. Next, in English medium, yeah, the classes will be from 6 PM to 9 PM, and on Monday, Wednesday, Friday, your beloved Negi sir and my senior in IIT Bombay. Negi sir was my senior in IIT Bombay. He'll be taking the heat transfer part 2 from 6 p.m. to 7:15, and on Tuesday, Thursday, Saturday, I'll be taking the class of thermodynamics part 1. Okay, and I'll be teaching you this subject from the basics. Okay. And from Monday to Saturday, Prakhar Srivastav sir will be teaching you manufacturing sciences. Okay. Okay. So please speak both languages. This lecture is in English medium, so I'll be mostly conversing in in this English language here. And don't worry, I have started thermodynamics in Hindi, but that is in Unacademy Plus platform. So I'll be talking about that Plus platform later on in this video. Okay. Next slide. Okay. Before starting thermodynamics, I want to ask you this one question. What is that one most important thing which you require to crack any competitive exam? Write down in the comment section. Okay, I'll read your comments in my phone here. Okay, write down in the comment section what is that one most important thing which you require to crack any competitive exam. Tell me the answers. One most important thing that you require to crack any competitive exam. Let's see who will get the right answer. Let's see. Write down in the comments. Sir, will you cover all topics in TD? In YouTube, I'll be teaching thermodynamics part 1, that is up to energy interactions. And in the Unacademy platform, I'm going to start thermodynamics in Hindi on 6th June. Okay, and in that I'll be covering whole of the thermodynamics in 1 month. Okay. So, okay, the answers are practice, determination, discipline, consistency, technique, self-confidence. Good, you got it right. Confidence, self-belief. If you don't have that confidence in you, you won't be able to crack any competitive exam, even if you have done a lot of practice. Okay, take that confidence with you. Wherever you go in life, do not lose that confidence. So I'll write here the most important thing, confidence. Confidence. I think I should use this medium line. Confidence or self-belief. If you don't have belief on yourself, you will not be able to clear any competitive exam. Okay. Even in the ESE interviews, or when you will be cracking GATE and you will be appearing for PSU interviews, sometimes you don't know the answer to a particular question. Okay, and at that point, the one who is taking your interview judges your confidence. You confidently say that, sir, I do not know the answer to this question. Okay, but this is the key. Confidence is the key. Okay, you have done a lot of practice, but you forget to take this thing with you. I am 100% sure that you will not do good in the exam. You will not do well in the exam. Okay, so do not lose your confidence ever. Okay. Next, speed and accuracy. Yeah, they are important part of of the preparation, but confidence is required. Sir, thermodynamics में numerical में very weak हूँ. Don't worry, I'll be taking a lot of numericals. I know the importance of practice. Just wait for 2-3 class. When we cover the basics, when we finish the basics, after that we'll be moving on to energy interactions, and in energy interactions I'll be taking a lot of questions. Okay. So this is the one most important thing, confidence. Okay. One pro tip that I have given you in this class is this. Okay. Next, guess the place for daily motivation. I have told you that I will be including one picture in the lecture. Okay, in the ongoing lecture, and you'll have to guess the picture, and I'll say some few words about that picture to motivate you, and so that you prepare well for it. Okay, so you stay motivated. Okay, because I believe that along with teaching, my motive is also to help you stay motivated for this exam. Okay. So please change the background to white. Is it a problem? Is it a problem? If it's a problem, I'll be changing the background in the next lecture, or let's see. Let us move on. Okay, will you teach total thermodynamics? In YouTube I'll be taking the thermodynamics part 1, okay, and in Unacademy Plus platform I'll be taking whole of the thermodynamics. I'm going to start thermodynamics there in Hindi language from 6th June. Don't worry, it will not be totally in Hindi, it will be a mixture of English and Hindi. Okay, writing is not visible. I'll increase my font, don't worry. Okay, engineering thermodynamics. What do you mean by this word thermodynamics? What do you mean by this word thermodynamics? Can you tell me? Can you tell me in the comment section? Can you tell me in the comment section what do you mean by this word thermodynamics? Okay, I want to interact with you guys, so interact with me as much as possible in the chat. I am reading your comments here. Okay, so what do you mean by thermodynamics? This word is sir, don't use red color, not visible clearly. Okay, this word is made up of two words, that is therm plus dynamics. Okay, what do you mean by therm? Therm means heat, okay, and dynamics. What do you mean by dynamics? Dynamics mean movement in a way, okay, in a way. So when you combine these two words, you get movement of heat. Movement of heat. This is a very basic definition, okay, in a very simple language. I've told you the definition of thermodynamics. I'll be teaching you in a very basic language, don't worry. So this is movement of heat, okay. Nowadays actually the definition of thermodynamics has been modified a lot because of a lot many branches are being associated with thermodynamics, but the basic definition is this: movement of heat in a very simple language. Okay, next, applications where we want to transfer the thermal energy. Applications of thermodynamics where we want to transfer the thermal energy. For example, power plant. Okay, power plants, automobiles, refrigerators. Okay, even in your electronic equipments where you want to deal with the heat part of that. Okay, so electronic equipments where you deal with the heat part, Okay, many of the atmospheric phenomena are governed by thermodynamics. Okay, many of the processes of our own body are governed by thermodynamics. Okay, we are continuously generating heat. Okay, so many of the processes of our body, our human body, is also governed by thermodynamics. Okay, so whatever I'm writing, this will be available to you in the PDF format, so don't worry about that. Just have to listen here carefully, okay, with your ears open. Okay, good. Study of movement of heat. Very good. Please change background in light mode. Okay, let me change the background then in light mode. Many of the guys are asking this, so let me change the background. I have made the slides using black background, so I think I'll not be able to change the background in this lecture. Okay, but I'll take care. In the next lecture I'll be preparing the slides with the white background. Don't worry about that. Okay, from GATE or ESE point of view, I'll tell you how much important this subject is. Okay, should I use writing is not visible? Don't worry, I'll be using the white background in the next lecture, and all these problems will be rectified. So from GATE or ESE point of view, let me tell you about GATE first of all. Okay, GATE, you can expect about 4 to 6 marks of the questions from thermodynamics. Okay, plus it also forms the basis of two important subjects that you will be studying. What are they? They are power plant engineering and IC engines, right? So thermodynamics forms the basis of these two subjects also, that is power plant engineering and IC engines. Okay, from power plant engineering, like if we see the previous year trends, minimum one question is coming in the GATE exam from 2015-16. Okay, every year minimum one question is there from this power plant engineering, and that question is very simple. Okay, 2 marks question is there, very simple question, and you have to prepare this topic as well. But before preparing power plant engineering, you have to prepare thermodynamics, because it forms the basis of these two subjects. Okay, let me give you an example. If the foundation of the building is not strong, the building will collapse. Okay, so this course is actually serving as a foundation for the other courses. Okay, so power plant engineering, you can expect a 2 marks question, and again from IC engines you can again expect a 2 marks question. Okay, every year, from 2014-15, every year we are getting a question on IC engines, whether it is an Otto cycle or diesel cycle, or sometimes you have to find the maximum temperature in the Otto cycle and diesel cycle. So these kind of questions are asked, and they are pretty simple. Okay, they are pretty simple. Okay, sir, please use white color sketch for writing. I will use this white background in the next lecture. Okay, let us go towards ESE. Okay, so in ESE many questions are asked from thermodynamics, many questions from thermodynamics. But the catch here is that in ESE mains, power plant engineering and IC engines, these two subjects become very important. Okay, very important. So if you study thermodynamics effectively, then only you will be able to understand power plant engineering and IC engines. Okay, and these are very important from ESE point of view. Okay, ignore this Uday Kumar. I don't know क्या दिक्कत है भाई उदय कुमार, हिंदी में बोलूं क्या? Please refrain from using this language. Okay, yeah. So what are we going to study in thermodynamics? Yeah, what are we going to study in thermodynamics part 1? So first of all, I'll be covering the basics, and I'll be starting with system, surroundings, and the universe portion. Okay, surroundings, universe. Then we'll be moving on to boundary. Then we'll be moving on to types of systems. Okay, then processes, different type of processes, isothermal, isobaric, adiabatic, polytropic processes, different type of processes we'll be studying. We'll be studying zeroth law of thermodynamics. Okay, we'll be studying first law of thermodynamics. Okay, and we'll be solving a lot of questions from thermodynamics, because that even after teaching you all these concepts and you learn these concepts, even after that you have to practice a lot. Okay, even if you don't practice the questions, you won't be able to solve the questions in the actual examination. Okay, so practice, will do a lot of practice of the questions. Just wait for 2-3 classes. After this these basics get over, we'll be doing a lot of practice. Okay, so let's move on to the next slide. Okay, Difference between thermodynamics and heat transfer. Tell me in the comment section. Difference, major difference between thermodynamics and heat transfer. Okay, tell me the difference between thermodynamics and heat transfer. What do we study in thermodynamics? What do we, what do we actually study in heat transfer? One major difference. Tell me. Maxwell relation. That is in heat transfer rate is calculated. Yes, good. And in thermodynamics, what about thermodynamics? Tell me in the comment section. Thermodynamics 2 in Unacademy is free of cost. It will be available on Plus platform, so you'll have to buy the subscription. Don't worry, I'll be explaining you the benefits of subscription as well. Don't worry, stay up to the end of this lecture. Okay. Whereas in amount of heat transfer, good, very good. In thermodynamics, we talk about the quantity part. I mean quantity of energy interactions taking place. For example, this much amount of heat has been transferred, or this much amount of work has been done. Okay, but in heat transfer, what do? We study about the rate of energy interactions, rate portion. Okay, so let me write this for you, and this will be available to you in the PDF. So in thermodynamics, what we study? We study about the quantity of energy transferred. Okay. Now let me tell you the energies that we will be dealing in thermodynamics will be heat and work. Okay. So in thermodynamics, we talk about the quantity of energy transferred. Okay, the quantity portion. But in heat transfer, what we do is we study about the rate of energy interaction. Okay, rate. Now, what do you mean by this word rate? Whenever this word rate comes now, in your mind there should be an expression that this means E upon T. Okay, any quantity upon time. Okay, any quantity upon time. Okay, so you write E in joules, time in seconds, that will be in watt. Okay, and here you will be measuring the energy interactions in joule or kilojoule. See, basically what my personal opinion is, I always used to solve, when I was preparing for GATE, or now also when I used to solve any numerical, I try to solve it in SI units. Okay, SI units. Why? Because when you solve the numerical in SI units, the chance of committing an error is very negligible. Okay, what you do is that whatever data is given to you, convert everything into SI units. Suppose specific heat is given to you in kilojoule per kilogram Kelvin. What you do is you convert it in joule per kilogram Kelvin. Okay, so you convert everything in SI units. What you will get? You will get the answer in SI units. Okay, and before filling the answer finally in the NAT question, or MCQ type question, before filling the answer, just check in the question that in which units you have to fill the answer. Okay, so this is my personal preference, and by this with this technique, I have actually removed my careless mistakes. So whatever data is given to you, always try to convert the data in SI units. You will get the final answer in SI units. Okay, and before filling the answer, just check in the question that in which units you have to fill the answer. So this is how you should proceed for solving a numerical. Okay, I'll be telling you more about this when we'll be solving the numericals. Okay, so quantity of energy transferred we measure in joule, and the rate of energy interaction, that is joule per second in watt. Okay, there is one more word which students generally tend to get confused. This gradient. What is this gradient? Whenever you see this word gradient, always think in your mind that this is some entity. Let me write entity. Okay. Some entity upon distance. Okay, distance or length or whatever you want to write. Okay, so whenever the word rate comes, it should be, you know, that quantity over time. And whenever this gradient word comes now, your mind should always see this equation, that some quantity over distance. Okay, some quantity over distance. Quantity, let us write quantity only. You will be more comfortable with this quantity. Okay, so quantity upon distance. This is just a basic definition of this word gradient. Okay, we'll be dealing with this word in the next lectures. Okay, this is just a basic definition. Okay, just a basic definition. How can you relate thermodynamics and fluid mechanics? Okay, gradient means changes. Yes, I know that, but I want to tell you that distance, change in distance, or I'm just telling you the basic part, that in the denominator the term will be of distance. Okay, this is just a basic definition. Let's move on to the next slide. Okay, how can you relate thermodynamics and fluid mechanics? Good question. How can you relate thermodynamics and fluid mechanics? Tell me about this thing. How can you relate thermodynamics and fluid mechanics? You guys have not marked your attendance here. Like the session, please. That is your attendance. Please like the session. So how can you relate thermody and fluid mechanics? Can anybody of you tell me? Write in the chat. Write in the chat. No comments? Okay. In thermodynamics, what do we study? Yeah. Amit Kumar Bata. Yes. Don't worry. Okay. In thermodynamics, what do you study? You study flow of heat. Okay. And in fluid mechanics, what do you study? Flow of fluid. Very nice. Macroscopic and microscopic. Okay. Heat moves from high temperature to low temperature, right? Okay, fluid moves from high total head. Okay, never say high pressure to low pressure. I'll tell you why. Okay, fluid moves from high total head to low total head naturally. Okay, low total head naturally. Heat flow and fluid flow. Very good. Okay, so fluid moves from high total head to low total head. Never say that fluid moves from high pressure to low pressure. Okay, why? You must have studied this Bernoulli's equation. P1 by rho g plus V square by 2g plus Z is equals to constant. This is what? This is pressure head. Okay, this is what? Velocity head or kinetic head, and this is what? Datum head. Okay, and summation of all these heads is the total head. So fluid moves from high total head to low total head. Okay, not from high pressure to low pressure. When you will be studying fluid mechanics, you will be dealing with these examples. Okay, so mark this as very important. Many of the students have confusion in this. Okay, next, yes, we have devices, by which we can move the heat from low temperature to high temperature. We'll be talking about those devices in the upcoming lectures. Okay, so devices to move heat from low T to high T. Okay. And similarly, here, if you want to reverse the fluid flow, if you want to reverse the flow of the fluid, we'll install a pump. Okay. So here also we have devices, you know, devices to reverse the direction of fluid flow. Okay, fluid flow. Yes. Okay. So this is how we can relate thermodynamics and fluid mechanics. Okay. Yeah. Change background in next slide, please. Dark Knight, I will not be able to change the background in the next slide because I have made the slides using the black background. But in the next lecture, don't worry, I'll be making the slide with the white background. Okay, don't worry about that. Okay. Ceramic plus also when you are going to start subjects in plus, I will be starting thermodynamics on 6th June. Okay. Let's move on to the next slide. Okay. System, surroundings, and universe. Let us start with system. Now most of you guys, I mean, they think, sir, this is very trivial. What are you teaching? System, surroundings, and universe. But I tell you guys that when you get a conceptual problem in GATE or in any exam, okay, many of the students will take wrong system and will get wrong answer. Okay, I myself will ask you some numericals when I will be teaching you this course. I will be giving you numericals in which you will be taking the wrong system and you will be getting the wrong answer. Okay, so the emphasis which I am giving on deciding the system is very important. Okay, so please listen carefully. Okay, system. Okay, let us start with this example. I have this fan in my room, okay, and I want to observe this fan. Okay, I asked you that I want to observe this fan. Then you will ask me, sir, what do you want to observe? Okay, then I'll say that I want to observe that at what speed it is rotating. Okay, so I have said two lines. Did you observe something? That observation comes second. Deciding what to observe comes first. Okay, deciding what to observe comes first. Okay, and whatever the region we are focusing on, that is our system. Okay, and please be careful of these two lines, that we have to decide what we have to observe. Okay, and what we have to observe in that comes second. Firstly, you have to decide what you have to observe. That is why I decided that I have to observe this fan. Okay, and the second question was from your side, that sir, what do you want to observe? Okay, so observation comes second, deciding what to observe comes first. Okay, and whatever region we are focusing upon, that is our system. Okay, so whatever region we are focusing upon, that is our system. Okay, so let me give you an example. Okay, let me draw a box here. Shapes. And again, okay. So this is A and this is B. Okay, so let this be A and this be B, and let us assume that the temperature of A is greater than temperature of B, and these walls are not insulated and heat can flow from A to B. Okay, nothing is given about the empty space. I am telling you nothing is given about the empty space. Okay, I'll get back to that empty space also, but now only A and B are given, and temperature of A is greater than temperature of B, so that heat can flow from A to B. Okay, so if I ask you a question that how much heat has been transferred, heat has been transferred from A, what will be your system? Your system in this case will be A. Okay, if I ask you that what is the relation, or how is the temperature distributed within A, so what will be the system? A will be the system. Okay, similarly, if I ask how much heat has been given to B, or how much heat B has received, in that case B becomes our system. Okay, what about A then? If our system is B, then A becomes our surroundings. Okay, so everything exterior to that system is surroundings. Okay, let's move on to the next slide. Everything exterior to the system is surroundings. Okay, and system plus surroundings make the universe. Okay, so now you will be having a confusion, because what you do is you actually go by the literal meaning of universe. Okay, here I was just talking about A and B. I did not talk about this empty space, this empty space, this empty space. Okay, okay, so here A plus B is our universe. A plus B is our universe. Okay, you have to take only those regions in your problem which are specified to you. Okay, nothing has been given you about that empty space. Okay, now let's take the second example. Let's take the second example. Let me draw the box again. Okay, okay, I'll try to avoid the red pen. Don't worry, in the next lecture I'll change the background to white. Okay, so this is my A and this is B, and now I say that this empty region is C. Okay, now I have given you that empty region is C. Okay, so now if I ask you the question that how much heat is transferred from A, what will be your system? What will be your system? Tell me in the comments. What will be your system in that case? If I ask you that how much heat is being transferred from A, or what is the temperature distribution within A, in that case what will be your system? What will be your system in that case? A. Okay, the system will be A. And in that case, what will be your surroundings now? Tell me. Now your surroundings will be B plus C. Okay, because now I mentioned this empty space as C. Okay, and now in this case, universe will be what? Universe will be A plus B plus C. Okay, yes, you got my point. So whatever regions that you have been given, only take those regions into consideration. Okay, so universe is equal to A plus B plus C. Yes, very good. So I'm reading your comments. Yes, B and C, very good. So universe will be A plus B plus C now. Okay, okay, so whatever the things, whatever the the portion that has been given to you, whatever the regions that have been specified to you, only consider those regions. Okay, I hope you get my point. I hope you get my point that the defining of system and surroundings is actually very important when you will be studying entropy now. Then you will be getting a lot of questions in which you will be facing a lot of difficulty in defining the system. And if you are not defining the system correctly, you'll get the wrong answers. Okay, so this is not a trivial portion. This is a very important portion of thermodynamics. This is the basics of thermodynamics. Okay. Yes. Very good. Very good. Next, let us move on to boundary. Okay. So I'll be teaching you boundary now. So they can be this boundary can be classified in two regions, that is rigid or movable and real or imaginary. Okay. What do you mean by this rigid boundary? Very simple. Suppose this is a room. This is a room and this is exchanging heat with the atmosphere. The room which I am in, okay, this is exchanging some heat with the atmosphere and it is having rigid boundaries. Okay. So rigid boundaries. Rigid boundaries. Okay. Movable. Example of movable. Can you tell me the example of movable boundary? Movable boundary. Can you tell me the example of movable boundary? Comment in comment section. Write in the comment section. Write in the comment section. Movable boundary. Yes, piston cylinder. Okay, piston cylinder. If the gas in the cylinder is my system, this piston is movable. Okay, so this piston cylinder arrangement, from this we can learn the movable boundary. Okay, what is this real boundary? What is this real boundary? The boundary that is tangible. That means that you can touch the boundary, you can see the boundary. Okay, touch the boundary. You can touch the boundary. Okay, what do you mean by this imaginary boundary? The one which is not tangible. Simple. Okay, suppose in the atmosphere I'm saying that this much amount, this region, how much this region is receiving this heat. Okay, so this is not tangible. Okay, you cannot see it. Not tangible. You can't see it. You can't see it. Okay. Yeah, piston cylinder. Right example. Correct example. Correct example. Very good. Okay. Pick of the day for you guys. Pick of the day for you guys. Tell me the pic, that where it was taken and what is this pic showing. Okay, tell me. Pic of the day. Just to give you a motivating lecture, just to give you some motivation. Okay, pick of the day. Tell me in the comment section. Isn't it close to heaven? No? Yes. I'll be giving you a picture in every lecture, so as to motivate you to study for this exam, to crack the exam with a good rank. Okay, tell me, where was this picture taken and what is this picture? What does this picture show? Yes, write in the comment section. At least try. Sir, voice is coming double. That is because of echo. I'll fix it in the next lecture. Don't worry. IITs. There are 23 IITs. Which IIT? IIT B. Yes, IIT B. But from which place in IIT Bombay? Can you tell me? Can you tell me the America? America, nahi, not America. This is our India only. Okay. Yes, it is from IIT Bombay. It is from IIT Bombay. But from which place in IIT Bombay? Can you tell me about this picture? Beach? No, it's not a beach. It's not a beach. IITB maybe, yes, IITB. It is from IITB. Powai, Powai Lake. Yes, you're correct. Powai Lake. Powai Lake, as seen from Hostel 13. Hostel 13. That was my hostel. So this was the view I was, I used to see for 2 years. This is from Hostel 13. I had my room on 7th floor. Okay, A wing, 706, A706. If anybody of you get selected there, do visit my room, A706. Okay, yes, Powai Lake. This is Powai Lake, and this is the view I used to see every day. But for this view, what you have to do is you have to work hard. Okay, because this view, this view deserves that kind of hard work. Okay, and you have to put that kind of hard work to get to this place. Okay, after my classes, let me tell you something. After my classes get you know my classes got over at 6:30, I guess, 6:30 p.m. After 6:30 p.m. I used to come to this place, to my room's balcony, and I used to sit here for half hour, 1 hour, and it was so peaceful. It was so peaceful there. I cannot describe those moments in words. Okay, they can only be experienced. So this is Powai Lake as seen from Hostel 13 IIT Bombay. Okay, and this is Hiranandani. Okay, this is Hiranandani. You must have seen this Hiranandani in many of the TV series also. So also motivate us for PSU. PSU is my dream. Okay, in the next lecture. In the next lecture. Okay. सर मैं अभी आईआईटी बॉम्बे गया था. नेक्स्ट टाइम आपसे मिलना चाहूँगा. आई लिव इन पंजाब. आई लिव इन Jalandhar. Come to Jalandhar, meet me. Okay. Currently I am living in Jalandhar. Sir, your BTech is from? My BTech is from NIT Jalandhar. Okay, and there is a lot of difference between NITs and IITs. I've experienced both the lives at IIT as well as at NIT. Okay, the culture of the NIT is they both are different. They cannot be compared. Specifically, IIT, the culture is superb. It's awesome, even for PGs, even for postgraduates. Okay. Okay. So I hope you like this view. Okay. I don't know about IIT, but I from Anna University. IIT Madras is there, close to Anna University. How come you don't know about the IIT? Anna University. IIT Madras is near Anna University. Yeah. Okay. So let us come back to the reality. Okay. Let us move on to the next slide. This is a dream for you. You have to work hard for this if you want to experience this view. Okay. Mumbai is awesome. Mumbai's life is great, and do hard work for this 6-7 months. Go to IIT Mumbai and experience all this. Okay, let's come back to reality. Types of systems. Got it? Okay. In the next lecture, I'll be presenting you some other thing. Okay, types of systems. Come back to reality. You are here studying types of systems. Okay, you have to study thermodynamics first if you want to go to IITB. Okay, types of systems. So we'll be studying 3 types of systems. Okay, open, closed, and isolated. Okay, what we'll be studying in these types of systems? Mass transfer. Is it there in open system? Energy transfer. Okay. So whenever I write this word energy, I've told you that in thermodynamics we'll be dealing with majorly, okay, majorly 2 types of energies, that is heat and work. There are a lot of energies and we'll be dealing with them too, but whenever this word comes, For now, heat and work should come in your mind. Okay. So in open system, mass transfer is there, energy transfer is also there. Okay. Yes, in open system. Example of any open system. Example of any open system. Our own body is an open system. We eat, we excrete. Okay. So mass transfer is there, energy transfer is also there. Our body is continuously generating heat. Okay. So mass transfer is there, energy transfer is there. Okay. In open system, our body is an example of open system. Closed system. In the closed system, mass transfer is not there. Okay. No mass transfer takes place. Energy transfer, yes. Energy transfer takes place in the closed system. Okay. In the form of heat or in the form of work. Okay. Consider a piston cylinder arrangement without the walls. Okay, without the walls. If you consider the piston cylinder arrangement without the walls, then it is an example of closed system. If you consider the piston cylinder arrangement with walls, then it becomes an example of open system. Okay, because from that walls, fuel will be entering, so mass is entering. So then it becomes an example of open system. Okay, energy transfer is there, mass transfer is also there. But if you consider the piston cylinder arrangement without the walls, then it is an example of closed system. Okay, no mass transfer is there, but yes, the gas present in the piston cylinder arrangement can do some work, so energy transfer is there. Okay. What is isolated system? Yes, isolated system. It is that system in which no mass transfer is there and no energy transfer is there. Okay. Universe is an example of isolated system. Why? Because all the processes that are occurring in system and surroundings, they are occurring within the universe. So it is a type of isolated system. Universe is an isolated system, right? So universe is an example of isolated system. Okay, let me give you one more example of isolated system. Don't worry, I'll give you one more example. Okay, let me draw a box and suppose this is my rigid insulated vessel. Okay, rigid insulated vessel. Don't worry, I'll be changing the background in the next lecture. Okay, I'll be coming with the white background. Don't worry. So this is what? This is rigid insulated vessel. Insulated vessel. Okay, this is an example of isolated system. An example of isolated system. How? Write down in the comment section. How? Yes, thermostat is isolated system. Very good. Sanjay Kumar, good. Good answer. Now tell me how this rigid insulated vessel is an example of isolated system. Tell me. Mass transfer can take place? Can any mass enter into this vessel, or can any mass leave this vessel? Is it a possibility? No. Okay. Does this vessel, is there any kind of energy interaction in this vessel? No. How? This vessel has rigid walls. That means no mass can enter. Okay. No heat will flow, neither mass nor heat transfer takes place. Very good, very good. Yes, no mass can enter. Okay. No work can be done. No work can be done. Rigid walls. Okay. Insulated. No heat flow takes place. So this is also an example of isolated system. Okay. So whenever a question comes in the paper, that whether this system is isolated or not, what you have to observe, whether any mass transfer will take place, whether any energy transfer will take place, and in that energy transfer consider both heat and work. Okay. Okay. So this rigid insulated vessel is also an example of isolated system. Right. So this is how you have to analyze the different systems. Okay. So in closed system, no mass transfer will take place, but energy transfer may take place. Okay. In open system, I've given the example of our own bodies, yeah, right? Mass transfer is there. We eat, we excrete. Okay, and we are continuously generating heat. So energy transfer is also there. We do some work. Okay. Closed system, I've already told you about the closed system. Isolated system, I've given you the example. Okay, no mass transfer will be there, no energy transfer will be there. Okay, great. Change inks are not visible. I'll be changing the ink. Don't worry. In the next lecture, don't worry about that. Okay. Also, open systems are referred as constant volume systems. Okay, and closed systems are referred as constant mass or fixed mass systems. Yeah. Okay, so we do not have to write all this. The PDF of this lecture will be available. Okay. Thermodynamic equilibrium. Thermodynamic equilibrium. What do you mean by thermodynamic equilibrium? Tell me in the comments section. What do you mean by thermodynamic equilibrium? Tell me about this term, thermodynamic equilibrium. Tell me about this word, thermodynamic equilibrium. Okay. Many of you will confuse it with thermal equilibrium. No, it is not the case. What do you mean by thermodynamic equilibrium? What do you mean when a system is in thermodynamic equilibrium? Okay, what do you mean by this? Let me write this question. What do you mean when a system is in thermodynamic equilibrium? Thermodynamic equilibrium. What do you mean by this? Mechanical, chemical, and physical equilibrium. Physical. Okay. Thermal. Yes. 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 Okay. Yes. Very nice. Very nice. Very nice. Okay. Never confuse this thermodynamic equilibrium with thermal equilibrium. Okay. Thermal equilibrium is a subset of this thermodynamic equilibrium. Okay. This thermodynamic equilibrium is a broad term and it consists of thermal equilibrium. Second, it consists of mechanical equilibrium. Okay. And third, it consists of here, let me write here, chemical equilibrium. Very, very nice. Okay. What do you mean by this thermal equilibrium, sir? What do you mean by this mechanical equilibrium? Or what is this chemical equilibrium? Okay, I explained you that thermodynamic equilibrium consists of actually these three terms, that is thermal equilibrium, mechanical equilibrium, and chemical equilibrium. Okay, thermal equilibrium means that in a system, very important, within a system, there is no temperature change within a system. Delta T is 0. Okay. Within a system, please be careful that within a system, delta T is 0 for thermal equilibrium. Okay. Great. This is relatively easier to understand. Next we come to mechanical equilibrium. Okay. For mechanical equilibrium, let me write the equation first of all, and then I will be explaining you how this equation comes. Okay. For mechanical equilibrium, delta P, what is this delta P? within system, please be careful that it is within the system. Okay, there is no pressure difference within the system. Delta P is 0. There is no pressure difference within the system. Okay, now let me explain you this mechanical equilibrium, how how we arrived at this term that delta P within the system is 0. Okay, suppose this is my system. Okay, and suppose this is my system. Okay, and it is not moving. Okay, it is not moving. It is not moving, so velocity is 0. Okay, generally we don't consider the datum head. Okay, that is the height difference. Okay, we neglect the datum head because its effect is very negligible, so neglect the datum head, neglect datum. Okay, the only term that is left is what? That pressure head term. You remember that Bernoulli's equation. Okay, the only term that is now left is the pressure head term. So for mechanical equilibrium, there should not be any pressure difference within the system. Within the system, this is 0. Okay, this is for a system which is fixed, which is not moving. Okay, if no mass is entering and no mass is leaving. If there is a system in which mass is entering and mass is exiting, that is a different phenomena. But if there is a system where no mass is entering and no mass is exiting, okay, this is how we arrive at this term, that delta P within the system is 0 from Bernoulli's equation. This is from Bernoulli's equation. Okay, I told you in that about this equation in the second slide only. Okay, so V is 0, no mass is entering, no mass is exiting, neglect datum. Okay, and you arrive at this term, that is pressure head within the system is 0. So delta P within the system should be 0. What do you mean by chemical equilibrium? This is very simple. No chemical reaction, no chemical reaction, no chemical reaction should be taking place, should be taking place within the system. Within the system. That means its composition must remain same. Okay, so that means its composition must remain same. Okay, just give me a minute. My mobile phone got switched off. I will not be able to read your comments. Just give me a second. Just give me a moment, right? Just give me a moment. Yeah. Okay. So this is what you mean by thermodynamic equilibrium. Okay, that there should not be any temperature difference within the system, that there should not be any pressure difference within the system, and the composition of the system, composition of the system must remain same. Okay, there should not be any chemical reaction, there should not be any chemical reaction taking place within the system. Within the system. Okay, I'm stressing on this word, within the system. Okay, if you have a system in which mass is entering and mass is exiting, then that is a different case. Then we cannot go by this definition or this procedure. That is a different case. We'll be doing that in when we'll be studying that steady flow energy equation. Okay, don't worry about that. So this is the basic of thermodynamic equilibrium. Okay. Okay, so this is what I had planned for lecture 1. What are the benefits of plus subscription? Okay, let me tell you a very basic benefit of this plus subscription is that we get to interact with you you guys in a better way. Okay, like when I'm teaching you on YouTube, I have to see your comments on my phone. Okay, and in that process some of the comments they're missed. I am not able to read all the comments, okay, when I am teaching on YouTube. But in this Unacademy Plus platform, the chat box is on the screen itself. So it is very helpful for us also, and it is very helpful for you guys also. No comment will get missed, and none of your doubts will get unanswered. Okay, every doubt of yours will be answered because I can actually see the live chat on my screen, right? So this is one great advantage of this plus platform. Okay, daily live classes are there. Yes, we have started a batch, mission mission batch mission batch for GATE ESE. Okay, our batch name is mission, and Sarvesh sir has started with the material science. Material science. The timings are 7:30 a.m. to 9 a.m. Okay. Okay. I will be starting thermodynamics in Hindi. This is in Hindi. Okay. This is Hindi. I will be starting thermodynamics in Hindi from 6th June. 6th June, and my class timings will be 9:30 a.m. to 1 p.m. Okay. In YouTube, I will be taking 3 classes per week. Okay, I'll be teaching you for three and a half hours on YouTube. But in Unacademy Plus platform, I'll be teaching you around for 15 hours. Okay, Monday to Friday. Monday to Friday, 3 hours class, and so I'll be able to complete the syllabus in a very short span of time on Unacademy Plus platform. Okay. Next, if you take the plus subscription, and we will also be giving you the crash course. Once our syllabus ends, we'll be also starting the crash course. Okay, so in one subscription, you are getting classes, you are getting crash course. Okay, also we are going to start a rank improvement batch from 15th June. 15th June. In the rank improvement batch, we'll be taking a lot of questions, total of 3,000, 4,000 questions from mechanical engineering. Okay, so this is the rank improvement batch. Okay, the medium of instruction is English and Hindi. This batch that we have started recently from 1st June, this is in Hindi. We have another batch which is going on in English, and Devendra Singh Negi sir is taking classes in that batch. He is teaching fluid mechanics there, and Apurup Rao sir is taking engineering mechanics there. Okay, and in this Hindi batch, Alok sir will be taking engineering mechanics. Okay, we'll be sharing the schedule with you guys. Okay, doubt clearing sessions are there. One important thing about plus subscription is every 4th class is the doubt clearing session. Every fourth class is the doubt clearing session. Okay, and also weekly tests are conducted, weekly quizzes are conducted in the Unacademy Plus platform. Okay, so this is the batch, mission batch. This is the mission batch that our team has started, that our Creatix team has started on Unacademy. This is the interface that I was talking about. See, here is my video, here will be my video, and here I'll be able to see the live chat. Okay, and I'll be able to answer all of your doubts. Okay, so this is the platform of Unacademy. Doubt clearing sessions are there. Every 4th class is the doubt clearing session. Every 4th class is the doubt clearing session. Live poll and leaderboard are again two very amazing features. Okay, whatever question that I'll be giving you on Unacademy, if it has 4 options, I can conduct a live poll there itself. Okay, so this is again a very awesome feature. So Unacademy Plus platform is actually very interactive. So this is what I personally like about that platform. Next, how can you buy the Unacademy subscription? You go to the unacademy.com or you go to the Unacademy app and select your course as GATE ESE. Okay, select your course as GATE ESE and click on Get Subscription. And these are the subscriptions that will be shown on your screen. Okay, 12 months subscription and 24 months subscription are actually quite cheap. Okay, this is just for 25,000 as compared to 1 month, 3 month or 6 month subscription. The 1 year subscription and 2 year subscriptions are very cheap as compared to 1 month and 3 months or 6 months subscription. Okay, so this is for 25,000 and 2 year subscription is for 30,000. Okay, you can apply my code Viresh10 and you'll be getting a 10% discount on the final payment. 10% discount on the final payment. Okay, so once you get the Plus subscription, you will be able to attend any educator's class. This is one more benefit for you. Okay, you can attend any educator's class in this GATE and ESE category. Okay, so this is one more benefit of Plus subscription. Okay, so EMI option is available on credit cards, and EMI option is also available on one debit card, that is HDFC. Okay, EMI option is available on HDFC debit card, but that is available on Unacademy website, not on the app. Okay, so if you want to purchase the subscription through debit card, if you have the HDFC debit card, the EMI option is available there. Okay, do not forget to use the code Viresh10. Show some love, show some support. Okay, if you want to learn thermodynamics, or if you want to learn with our team, because we have started the full-fledged batch for GATE ESE, and we'll be covering that syllabus by the mid of November. Okay, and after the mid of November, we'll be starting the crash course for revision. So that is a great advantage for you, that in one subscription you will be getting all those things. This is our Telegram channel. Do subscribe to it. What will be the advantage of joining this Telegram channel? Quizzes. We post quizzes here. We post the PDF of the notes here in this Telegram channel. Okay, this Telegram channel you can join. This is the tiny URL for that. Okay, so GATE Unacademy ME. GATE Unacademy ME. This is the channel name. Okay. Okay. So this was for this class. Connect with me on Facebook profile. My Facebook profile Viresh Kumar. And this is the Facebook group again. Unacademy, do follow me on Unacademy for all the latest courses, for all the special classes that I'll be taking on the Unacademy platform. The special classes are free of cost. Okay, and Instagram, if you want to connect with me on Instagram, Viresh_05 is my username. Okay, so thank you guys for attending the lecture, and I'll see you on Thursday same time with the lecture 2, and I'll be moving on further with the basic concepts of thermodynamics. Okay, thank you, all the best, prepare well, study hard. Okay, and do remember that view. Okay, study for that view.